Hi, my name is Prasan Thomas, and today I am presenting my MSc research project titled Automated Detection of Malicious Website through URL Analysis using Cybersecurity and Machine Learning. This work combines machine learning with secure system design to create a real-world phishing detection solution. And coming to the introduction section, the phishing is a social engineering scheme designed to steal personal information about a user without their permission. And phishing continues to be one of the most common and damaging cyber threats. Attackers constantly evolve their techniques to trick use into revealing sensitive information. And traditional defense like blacklist often fail because phishing website appears and disappears very quickly. This creates a need for proactive and intelligent detection methods, and this is where machine learning becomes a powerful tool. And then coming to the related work, existing research focus heavily on improving model accuracy and feature engineering using methods such as URL analysis, host-based features, and external reputation signals. However, only a few work address the problem of secure deployment, that is, how to take a trained model and implement it safely into a real world operational environment. And then coming to the research question objective, my question is that how can machine learning be used to effectively and securely detect phishing websites, and how can these models be implemented to a secure operational web application as well. And I have some of the key objectives like process a large data set, train and evaluate classifiers, identify the best model, and develop a secure application. And then coming to the research gap, most studies stop once machine learning model reaches a good accuracy score, but in real life, deploying such a model requires API securing, monitoring, audit logging, and input validation, and also integration with the cybersecurity workflows. And my project fills the gaps by creating a secure and end-to-end operational framework, not just an academic model. And then coming to the methodology part, we have the collected data. I collected the 11,430 URLs, and each URLs are 87 features, and I pre-post the data. Then I select the features, and then I trust train and assessing the performance of the models as well. And then coming to the system architecture, the diagram shows the full system. On the first, the user submit a URL through the interface. Then the Flask API layer handles the authentication, rate limiting, and the input validation. And the feature extractor dynamically generate all the required features, and then the ML engine predicts whether the URL is phishing or not. And finally, the security monitor component logs all activity and generates intelligence for analysts. And this holistic diagram makes a solution practical for real world use. And then coming to the implementation part, I use the Python programming language for to develop this model, and it consists of skitlearn, pandas, joblib, and then the frameworks and API development use the Flask limiter and the middleware as well. And then coming to the results, all the three models performed well, but random forest clearly outperformed the others. It achieved 95.9 percentage of accuracy, and the precision achieved 95.6, and the recall 96.2 percentage as well, and an Excel ROC AUC of 0.9927. These results confirm that ensemble methods are very effective in the complex cybersecurity tasks. And then coming to the cybersecurity performance dashboard to evaluate the model from a cybersecurity perspective, not just an MLE perspective, I created a security performance dashboard. The random forest model method exceed the 95% target across all KPIs, and this include threat detection, false alarm rate, accuracy, and overall reliability. And then coming to the deep dive, it is the forest confusion matrix. Here we see how the model performs in practice. It correctly identified 1,100 phishing sites and 1,097 legitimate sites. There were 46 false alarms only and 43 misthreads. In cybersecurity, misthreads are the most critical metric and a value. This is how is this low. This low is a major achievement. And then coming to the model learned, the top predictive features that include external reputation, and then the URL lexical patterns, domain and host info, web page content. Inside the model learned that a combination of a site reputation, the structure of its URL, and its content are strongest indication of phishing. And then the coming to the cybersecurity evaluation, the model outputs probability scores which enabled me to design a tiered response system. And first one is the save zone, then the review zone, then the block zone as well. And the result is this makes the tool practical, save analysts time and focus effort where it is most needed. And then coming to the conclusion, to summarize, the project achieved the three main outcomes. One is the build a high performance phishing detection model, and then the other one is identified the most important features that attackers may manipulate, and the next one is developed a secure end-to-end system for real-time deployment. And this work goes beyond academic model by demonstrating a practical, secure cybersecurity solution. And the future work is that in future I plan to integrate dynamic web page analysis to explore deep learning models like LSTMs for sequential URL patterns and create an adaptive learning system that automatically retrains the model as new phishing techniques appear. That's all about the presentation. Thank you. And then we can go to the code as well. Um, in this folder, I saved the codes for this is the web page code and this is the model code. I just opened it before. So this is the code of the model and this is the code of the web page as well. So this is a sophisticated Flask-based web application that leverages machine learning to detect phishing website by analyzing the URL characteristics and the web page content. This and the application serves an intelligent security tool can distinguish between the legitimate malicious URLs through advanced features extraction and predictive modeling at its core system. The system utilized a pre-trained machine learning model that has been trained on 87 distinct URL and web page features to make accurate predictions about whether a given URL represents a phishing attempt or a legitimate website. And these are the course configuration, security configuration, and this is about the rate limiting configuration, and this is the logging configuration. This is the security monitoring, and this is the API key management section. This is the load the train report components. This is the feature extractor. This is the security middleware. The machine learning pipeline processes these extracted features through a standardized workflow, evolving feature scaling and selection before feeding them. And the application demonstrates a comprehensive approach to cybersecurity to combine multiple detection strategies. It analyzes the URL syntax that fishers commonly use, and examines technical web page characteristics that may indicate malicious intent, and leverages the power of machine learning to identify the sub patterns and all. Just added the external types, X-frame option, accesses, then I will show the model code. And this is the code as well. The cell one is the library imports. It will include pandas, numpy, matplotlib, cbone, skla, and joblib, and all. And then coming to cell two, it is the data loading. This I loaded the data and all. Then coming to the cell three, it is the data information and statistics. It provides a comprehensive information about the data set and all. And then coming to the next cell, it is the data quality check. Here we check the quality of the data and all. Then coming to next slide, it is the target variable analysis. This cell distributes the target variables. And then coming to the next slide, the target distribution visualization. This will creates a bar chart visualization of the target variable distributing using matplotlib. And this the green bar is for the legitimate and the red bar is for the phishing as well. So we have equal amount of phishing and legitimate data, so it's showing the same graph. Coming to the next cell, which is the feature identification. Then it is then next cell is the correlation matrix. This cell creates a large heat map visualization showing the correlation matrix between the numerical features and all. And the correlation matrix helps to identify the relationship between the features, which is important for understanding feature redundancy and potential multi-collinearity. And then coming to the next slide, it is the feature target correlation. And next cell is the URL column removal. And then the next is the target variable encoding. Then this is the feature target separation. Then the training and testing split. Then the feature scaling. Then the feature selection. Then model initialization and model training, result comparison. We have only limited time, so I'm showing it fastly. Performance visualization and best model selection. This is also a graph. We can get the best model by identifying the accuracy, finding the model best maximum accuracy value and all. And then coming to this, the confusion. This is the finding the random forest, and this is the confusion metric as well. Then the classification of the report, then the ROC curve, then the feature important analysis is the feature important analysis. Then the saving model, saving scalar cells have been fitted, and then the save feature selection. After this, this is the cybersecurity metrics. Then and the model confidence distribution graph, security action zones, and security outcome graphs. And it is the phishing risk indicators and phishing category graphs. The prediction phishing threat detection graphs, security threshold optimization graph. Then we can selecting the best model from here. Here scalar. Then we are selecting the feature selector and selected features. Then the model metadata and all the components loaded safely. And this is a prediction created and we, then the text prediction. This will demonstrate how to use the prediction function by and all. And then we can go to the demo or working model. So this is the folder where I saved all the codes and the data sets and things. And so by on the path bar we can go to the command prompt. So here we can enter when slash scripts slash activate, then we enter to the thesis bar. So we can enter here python space app.py. This is the folder and name that I saved over there, the web application code. So within 5 to 10 seconds we will get a idea, sorry, the IP and get access to the web page as well. So mm, yeah, we got on this we can get the phishing URL detector. Sorry, it is the model data false accuracy. We can see the accuracy and 15 select model, and the security features enabled is rate limiting, API key, security headers, course configuration, input validation, request logging, threat intelligence, and suspicious IP address. And the API endpoints are there here mentioned, and then the servers. So here is the IP for the access to the web page, and the security features all are showing us below. And then we can copy the path, sorry, the IP. We can copy the IP and paste this on the browser. So this is the interface of the web page. So here I added five samples of sample URLs. We can use these samples or we can enter any of the URLs from we have. We can check it over here. So for an example, I'm just searching www.youtube.co. Then we can analyze the URL. So it is URL is safe and it is to have the confidence of 74% and the accuracy of 95.9. So we can see the security features of over here. This is a rate limiting, API authentication, security headers, and validation, and etc. that I mentioned before. So and then we in the API section, API testing section, we can see the system health, get the statistics, and we can get the reputation, and we can get the report. We can see the threats and all. We can see the batch analysis, and from the statistics section we can see the total scans I have done, phishing scans and all. And then for an example I will show you one phishing websites I have example. So this is the web page of phishing detector, that it is have the 85% confidence that this is phishing, and the accuracy is 95.9 as well. So for this URL also we can see the statistics, reputations, report, uh, threats and all, and in the statistics section also we can see the phishing detector total scans, legitimate sites, and detection rate as well, and system information also. So this is all about my project and all. Thank you for listening and my presentation and all. Okay, thank you.